Welcome you all viewers. Today's session we are going to see about the subject name Power Electronics and the subject code is EE8552 and the topic of this video session is Introduction to Power Electronics presented by M. Umameshwari, AP Department, RMD Engineering College. Let us move to today's video session. Now, the introduction of power electronics. What is power electronics? It is concerned with the application of electronic principles in situations which are rated at power level rather than signal level. When we take the basic signal devices, say a diode and a BJT, which is all related to small signal levels, whereas power electronics is the uh, subject where we concerned about the application of electronics where the signals are rated at power level. And the power electronics you can also convey it as it is the electronics applied to conversion and control of electric power. So what is the conversion we are doing here is we are converting one form of power into another form, either AC to DC or DC to AC. Okay, and the constant DC to variable DC. So in this way we are converting the power and we are also controlling the power, electrical power. We are also varying the voltage. And so in this way the power electronics is the electronics applied to the conversion and control of electric power. And the range of power scale is milliwatts, megawatts range and gigawatts range, and this is the general structure of power electronic system. So with this help of block diagram we are able to understand the power flow, what is happening and how the power converter is working and what is the obtained output. So suppose this is your power input and which is given to the power converter, and the power converter is controlled with the help of a controller, and the controlled output is given to the power output. So we are able to obtain the power. Okay, let us take an example. The power converter we are dealing here is the rectifier. So for a rectifier, your input is power input is AC and the power output is DC. And for a rectifier, it converts AC, fixed AC to variable DC is the output, power input. Fixed AC to variable DC is the power output. So what is the need of controller here? Now in order to vary the output voltage, you have to vary the firing angle given to the rectifier devices connected, which is say for example we are connected thyristors in the rectifier, full bridge circuit, single phase full bridge converter we are using. There we have connected rectifiers. Now we have to provide control signals to these rectifiers, that is the thyristors, in order to trigger at a particular instant so that we are obtaining the regulated voltage or variable DC voltage. There we go for this controller. The controller takes the input from the reference signal and it also senses the corresponding feedback voltage and give the measurements of the output signals to the controller. The controller calculates the error between the reference signals and the feedback signal, and the corresponding control signal is generated. For example, I would like to give you an application oriented here. It is the fan. Let us take the load as the fan. Okay, so here what is the regulation happening? Let us take an AC fan load induction motor. So here power input is AC and your output is also AC, where we require a variation in the speed of the fan. So your output should be varied. So the output voltage should be varied. So what is the converter we'll go for? Let us take, we'll go for an AC to AC converter, whereas frequency is remaining the same. We are going for an AC voltage regulator. Okay, AC voltage regulator we are using it. Suppose the speed of the fan is at 500 rpm and we require the reference speed as 800 rpm. 800 rpm is the reference speed, whereas the actual rotation speed of the fan is 500 rpm. So there is an error in the rpm with respect to the reference value. 300 rpm is the error. So this error is calculated by the controller. Okay, so this feedback sensor senses the speed of the load connected, which is the AC fan connected here. So it is sensed as 500 and the reference is given as 800. So the error between this speed is 300 RPM. So with respect to this 300 RPM, what we have to do? We have to increase the voltage in the output terminal, AC output. Then only the speed will increases. So in order to increase the output voltage, we have to correspondingly give the triggering pulses to the power converter such that the AC output voltage is increased. In this manner, the controller generates the signal such that the corresponding speed is obtained. So we are going for a controller. The controller also senses the feed forward signals, that is the measurement of the input signals, and correspondingly generate the control input to the power converter. So in this way, the AC power is converted into variable AC power according to the requirement of the load connected here. Example we have taken is a single phase induction motor fan load. Here the example we have taken is to increase the speed of the load. So similar way, in order to decrease the speed of the load, the control signals are generated accordingly. So from this example, we are able to understand this general structure of this power electronic systems. What is power electronic devices? We have seen what is power electronics. It is this is here power electronics applied for conversion, electronics applied for conversion and control of electric power. Now, what is power electronic devices? So, these power electronic devices that are used in power processing circuits to convert or control of electric power, which means that the devices which you are using to processing the signal in order to convert from one form to other form and control to vary the voltage of electric power. So power electronic devices, previously vacuum devices, mercury arc rectifier, etc. are used, whereas they are rarely used. Now with respect to the invention of semiconductor devices in the 1980s, major power electronic devices are used with respect to these semiconductor devices. So what is this power semiconductor devices? It is same as that of the power electronic devices. These devices are made up of silicon material. Hence the name, it is named as power semiconductor devices. Now, this is the classification of power electronic devices. With respect to the terminals, it has been connected. So, the power electronic devices classified with respect to two terminal devices and three terminal devices. The two terminal devices are PIN diode, PIN diode, Schottky diode. So, and the three terminal devices are power MOSFET, metal oxide semiconductor field effect transistor, JFET, junction field effect transistor, IGBT, insulated gate bipolar transistor, and BJT, bipolar junction transistor, and thyristor or SCR. So these are classified depending upon the terminals. For example, for diode, it is a two-terminal device, and Schottky diode is a two-terminal device, anode and cathode. So with respect to the three terminals, it is classified like this. For power MOSFET, it is the gate, drain, source. And similarly for JFET, it is the gate, drain and source. And for BJT, it is base, collector and emitter. And for thyristor, it is anode, cathode and the gate terminal. So with respect to the terminals they are having, they are classified like this. And again, it is specified as these Schottky diode, power MOSFET, JFET are specified as majority carrier devices, which means that the power flow, the current flow in these devices is due to the majority carrier devices. And this IGBT, BJT, thyristor and PIN diode are classified as minority carrier devices. The current flow in these devices are due to the minority charge carriers. Hence, these devices are classified as minority carrier devices. Now, the classification of power electronics with respect to the controlled and half controlled and fully controlled with respect to the control. So, uncontrolled device. So, we say diode is an uncontrolled device. Why? Because the control of the output is we are not able to vary here. Okay, once we give the input, the diode turns on, and once the the input is turned off, the diode turns off. So it is an uncontrolled device. Whereas thyristor we can consider as an half controlled device. Why? Because we are able to turn on with the help of control signal, that is the gate signal, but turn off only by the power circuit. So thyristor is an half control device. And the next one is the power MOSFET, IGBT, GTO, IGCT are known as fully controlled device. Why? Because these devices we are able to turn on and turn off by the control signals. And these devices are called as fully controlled device. Thank you.